The paper discusses the concept of technical debt, TD, in software development, which represents the implied cost of future reworking resulting from earlier choices of easy but limited solutions. It is often considered an issue to be addressed in software development and maintenance practice, but it is also acknowledged that TD can be both good and bad. The study aims to collectively investigate practitioners' opinions on the various perspectives of TD from a large collection of articles. The authors conducted a gray literature review on articles systematically collected from 3 mainstream technology forums and adopted natural language processing techniques like topic modeling and sentiment analysis to achieve a systematic and comprehensive understanding. They also used ChatGPT to support the topic interpretation. The results of the study identified 8 main topics and 43 subtopics related to TD. The authors found that practitioners' collective opinions on TD include unclear roles and a lack of engagement as challenges, while active management supports collaboration and mitigates the impact of TD on the source code. The paper concludes that future research efforts should focus on the developers' issues with TD while consolidating and improving the good practices. Moreover, research efforts should also focus on AI-driven TD detection and management, as well as an analysis of the effect of TD on current software development methodologies such as DevOps. This study examines the opinions and discussions of practitioners on technical debt, TD, in software development, leveraging data from 3 prominent online platforms: Stack Overflow, Medium, and DZone. The research process involves data extraction, pre-processing, informativeness filtering, topic modeling, topic filtering, and opinion mining. Data extraction employed different strategies for each platform due to varying API availability and crawling policies. For Stack Overflow, API-based content crawling was used to retrieve questions and answers related to selected tracing tools. Medium's policy prohibited direct crawling, so historical articles with specific tags were obtained using tools like Beautiful Soup. DZone adopted a hybrid approach, combining manual search and Beautiful Soup for article content crawling. The data analysis process, illustrated in Figure 2, consists of 5 steps. Pre-processing involves dividing texts into sentence-level instances, building bigram and trigram models, and performing text processing activities such as lemmatization. Informativeness filtering uses a trained text classifier to identify sentences containing useful information about TD. Topic modeling detects main topics using techniques like Gibbs sampling Dirichlet multinomial mixture, GSDMM, or traditional latent Dirichlet allocation, LDA. Topic filtering maps each sentence to its corresponding topic, and opinion mining extracts collective sentiment regarding each topic. The study utilizes ChatGPT-driven techniques for topic interpretation, adapting methods from Janes et al.'s study. ChatGPT, an artificial intelligence chatbot developed by OpenAI, supports effective topic interpretation and summarization. The newly released GPT-4 model is employed for topic extraction, demonstrating higher reasoning capacity and conciseness compared to the legacy GPT 3.5 model. The research ensures verifiability and replicability by publishing the complete raw data in a replication package. The results, presented in Section 3, address the proposed research questions, providing insights into practitioners' opinions and discussions on TD in software development. The paper discusses the analysis of technical debt, TD, in software development, focusing on its cost, management, and impact. It begins by pre-processing crawled textual data from social media platforms, including Stack Overflow, Medium, and Zone, to obtain a dataset of sentences. The authors then use a naive Bayes classifier to identify informative sentences related to TD, achieving an accuracy of 0.843. Next, they employ the collapsed Gibbs sampling Dirichlet multinomial mixture, GSDMM, model to extract topics from the informative sentences. This results in 8 main topics, which are further analyzed to identify subtopics. The main topics include discussions on the true cost of TD, managing TD through a team-centric approach, paying down TD in agile sprints, understanding the business impact of TD, measuring TD, TD in product development, balancing new features and TD, and code quality and TD. The subtopics under the true cost of TD include the long-term consequences of shortcuts in software design, choosing quick solutions and incurring TD, balancing speed and sustainability in TD payment, financial analogies in TD, high cost of TD in financial terms, short-term gains versus long-term costs, and the lifecycle of TD in software development. In terms of managing TD, the subtopics cover solving TD through team collaboration, prioritizing TD, and incorporating regular reduction of technical debt into the product lifecycle. The paper highlights the importance of understanding and managing TD to prevent it from hindering future development and to ensure sustainable software development. Effective management of technical debt, TD, is crucial for software development teams. Practitioners emphasize the importance of collaboration, understanding, and proper tools and strategies to mitigate TD. To manage TD, teams must allocate resources, prioritize tasks, and address TD and sprint backlogs. Agile teams can benefit from continuous TD management, where clean code is linked to agile development and continuous delivery. Practitioners highlight the significance of understanding TD as a team, including the role of engineers, architects, and company leadership. Decision-making activities require team involvement, and communication gaps can lead to poor decision-making. Engineers play a crucial role in managing TD, as they are often the direct inducers of TD. To pay down TD in agile sprints, teams must allocate resources, prioritize tasks, and address TD in sprint backlogs. Prioritizing TD-related tasks in sprint backlogs is essential, and teams should assess each item of TD, understanding its impact on the product and user. Consistently including TD in sprint backlogs with elaborate estimation and prioritization ensures that it is paid down regularly. The business impact of TD is a critical concern, as unchecked TD can impact development efficiency, software product quality, and customer satisfaction. Practitioners acknowledge that TD can hurt businesses in the long run, resulting in costs from fixing problems, reputational risk, or regulatory action. Reducing TD means limiting its potential cost on the business level, but organizations often have little idea of how much technical debt they carry in their code. To track the cost of TD, tools like StepSize can help capture and track TD from workflow, allowing teams to quantify its cost to the business and prioritize the most important debt. TD can also impact team morale and productivity, and implementing a process for managing TD can positively influence engineering team morale and customer satisfaction. Evaluating the business risks of TD is critical, and practitioners propose building a debt limit and quick feedback to reduce risks. Measuring and managing technical debt, TD, is crucial for software project teams. Metrics such as the number of bugs, code quality scores, and impact on maintenance cost are commonly used to track and manage TD. However, calculating the exact level of TD can be challenging, and the number of violations in terms of standards or defined rules can be a useful variable for TD measurement. SonarQube is a popular tool used for measuring and managing TD, providing features that support efficient refactoring to reduce identified TD. In product development, managing TD is a necessary aspect of maintaining a product focus. Balancing quality and speed is crucial, as prioritizing rapid delivery over quality can lead to increased TD. Product managers, engineers, and product owners must balance this with the need for quality and long-term value. In fast-paced business environments, product teams face the dilemma of delivering new features quickly or focusing on quality and incurring TD. Managing TD in product development teams requires attention from various stakeholders, including data and security engineers, managers, and senior architects. The balancing act between product quality and fast delivery often occurs, leading to shortcuts and unattended critical decisions. Effective management of TD involves prioritizing maintenance work, such as bug fixes and code improvements, while working on new features. Code quality and TD are closely related, and testing plays a vital role in managing TD. Automated testing, in particular, can quickly identify and address bugs, ensuring that the development process does not add to the TD. Testing is also essential for maintaining code quality and reducing the long-term cost associated with TD. In microservice architectures, testing is key to managing TD, particularly when changes in code and architecture are frequent. Opinion mining using the Vader method can assess the sentiment of each informative sentence and the overall sentiment of each topic. By comparing the sentiment percentages of each main topic to the average sentiment percentage of all sentences, the benefits and issues of each topic can be determined. The research paper discusses the concept of technical debt, TD, in software development, focusing on its implications and management strategies. It highlights that TD is a common issue in software development, where quick fixes are often prioritized over long-term sustainability. The paper presents a sentiment analysis of various aspects related to TD, including its true cost, management, payment in agile sprints, business impact, measurement tools, role in product development, balancing new features, and code quality. The sentiment analysis reveals that practitioners generally have negative opinions about the long-term consequences of TD, but they view it positively as a quick solution. There is also a positive sentiment towards the high cost of TD in financial terms and the comparison between short-term gains and long-term costs. However, the discussion on balancing speed and sustainability in TD payment is viewed negatively. In terms of managing TD, the paper suggests that team collaboration, specific tools, and strategies can help reduce TD. The role of engineers in managing TD is highlighted, along with the importance of team involvement in decision-making. The business impact of TD is significant, affecting company risk, team morale, and productivity. Measuring TD using various tools and metrics is crucial for understanding its extent and managing it effectively. The paper also explores the trade-offs between quality and speed in product development, where TD plays a critical role. It emphasizes the need for balancing new features and TD in software development, allocating resources appropriately, and integrating TD management into feature development. Finally, the importance of code quality and testing in managing TD is discussed, highlighting the use of data metrics, automated testing, and continuous improvement of code quality. Overall, the paper provides a comprehensive overview of technical debt, its implications, and strategies for managing it effectively in software development. It emphasizes the importance of balancing short-term needs with long-term sustainability and the critical role of team collaboration, measurement tools, and code quality in managing TD. The paper discusses the collective opinions of practitioners on technical debt, TD, in software development. It highlights that practitioners have mixed opinions on managing TD, with some viewing it as a necessary evil for short-term gains, while others are concerned about its negative effects. The paper also explores various strategies for managing TD, including team collaboration, adopting proper tools and strategies, and enhancing collective understanding of TD. It further discusses the importance of paying down TD in agile sprints, understanding its business impact, and measuring TD with appropriate tools and metrics. The paper also touches upon the role of testing in code quality and the balance between new features and TD in software development. The paper uses natural language processing techniques to analyze textual data from various forums and social media platforms. It identifies 8 main topics related to TD and further models these topics to obtain subtopics. The sentiment analysis reveals that practitioners have positive opinions on solving TD through team collaboration, adopting proper tools and strategies, and understanding and managing TD as a team. However, they have negative opinions regarding unclear roles in TD management and the impact of TD on team morale and productivity. The paper also discusses the potential benefits and issues associated with managing TD. It highlights that active managing and paying down TD can lead to quick delivery and fixes to the code base, encourage collaboration among team members, and help maintain sustainable development practices. However, inadequate tools to track and measure TD, overemphasis on business risk, and unbalance between pushing new features and quality can lead to recurring issues in managing TD. Finally, the paper discusses threats to validity, including construct validity and internal validity. It outlines strategies to mitigate these threats, such as independent review and collaboration among authors, broad search strains, and snowballing processes to ensure a comprehensive set of results. The paper discusses the application of inclusion and exclusion in a multivocal literature review on open tracing tools, considering both academic and gray literature. It highlights the importance of mitigating threats to validity, such as researcher opinions and experiences, by evaluating sources independently. The study also addresses external validity, conclusion validity, and related work in the field of technical debt. Technical debt, TD, is a metaphor that reflects technical compromises that ultimately negatively affect source code maintenance. Various previous studies have investigated its impact, evolution, and management. For instance, Li et al. Surveyed 94 studies to systematically map the debt type, highlighting ambiguity in the broad definition of TD. Similarly, Ernst et al. Surveyed 1,831 participants and conducted follow-up interviews with 7 software engineers, proposing a technical debt timeline to improve management and tooling strategies. Recent studies surveyed the opinion and technical experience of developers on TD. For example, Rocha et al. Presented the results of an online survey with 74 participants from the Brazilian software industry, aiming to understand why technical debt is introduced, eliminated, and managed, mainly at the code level. Raymack et al. Investigated TD by preparing and conducting a family of surveys, receiving 653 valid responses from 6 countries. The paper differentiates from previous related work on surveying developer opinions for the scope, methodology, and size of the surveyed opinions. It employed 2 novel methodological choices for the related work: the use of LLMs for data synthesis and the broader scope. The study aimed to investigate, collect, and classify developers' opinions into major topics to provide a comprehensive and concise view of possible new research opportunities and practitioners' suggestions for consolidating good practices while averting non-optimal ones. The paper concludes that future research efforts should focus on AI-driven TD detection and management, as well as an analysis of the effect of TD on current software development methodologies such as DevOps. It also provides a list of references for further reading on the topic of technical debt.